This topic is areas of rectangles with the same perimeter. And our first problem says a rectangular lot is 130 yards long and 85 yards wide. I'm going to draw a little sketch of this and then label this 130 yards, 85 wide. The rest of the problem says give the length and the width of another rectangular lot that has the same perimeter but a larger area. Okay, I think I'm going to start by drawing another rectangle. And this is not going to be drawn to scale, but let's drop the length by 5 yards. So let's make it only 125 yards. And if we do that, if we drop the length by 5, we're going to have to add 5 to the width. That's the only way that we're going to keep our perimeter, the distance around, the same. So let's find out the area of each of these rectangles, and we'll find out if dropping this one by 5 and upping this one by 5 will give us a larger area for this rectangle right here. Remember, area is the inside of this, so we're going to do length times width. So for our first one, 130 times 85. 24 and 10. So we have 11,050 square yards. For our second one, 125 times 90. And I don't need to do that first line. I'm just going to bump it over to the tens place. 18 and 4 is 22. That'll be 11. So we have 11,250 square yards. So we have found already two rectangles that have the same perimeter. We know they have the same perimeter because all I did was drop this one by 5 and add that 5 to this one over here. So when I add these dimensions right here, they're going to be the same. And these dimensions right here, they're going to be the same. But the area for our second one is larger. So to answer this question, our new width would be 90 yards and our new length would be 125 yards. And here's another example. This time we have a rectangular field that's 125 meters by 90 meters. And coincidentally enough, that's exactly what we just ended with. And this one asked to find the same perimeter but a smaller area. So we already know an answer to this can be 130 by 85, but let's try a different one. Let's find out if we have a pattern going on here. If we drop this to 120 meters and then we raise the other one to 95 meters, will it have a larger area like we would expect? Because the last time when we dropped the length and we upped the width, we got a larger area. And I think that's going to work until you get to certain dimensions, in which case it'll eventually even out. But let's find out what that will do, since we already know an answer that will work. So again, we know that this was, what was it, 11,250. We don't really need to multiply that out again. And this one is 120 by 95. Let's see, that'll be 6, 18, 10, 14. So yes, it did. This one would be 11,400, and this one was 11,250. They're square meters. So by dropping this length right here and upping the width, we did increase it even more. So let's do the opposite. Except let's not do 130. Let's just go up. Let's go up by 25. So 150, which means we will have to go down by 25 right here. So if we go down by 25 here, we'll have what, 65? So that would be 65 meters. So let's find out what is 150 times 65. That's going to be 0, 25, 0, 30, and 9. Looks like it's going to be fairly significantly smaller, which is what we would expect, 9,750 square meters. So anytime you're doing a problem like this, I encourage you to look for patterns like that. And really, there's no one correct answer. All you had to do is find any length of rectangle or any dimensions of rectangle that will give you the same perimeter but smaller areas. So our answer for this one, I'm going to put the width as 65 meters and the length as 150.